All right, so what we're going to do here then is we're going to talk about parallel circuits. A parallel circuit is going to be a circuit that has a battery, and now you're going to see that it's drawn a little bit differently. For our series circuits, every one of them had one path. Well, on this series circuit here, or parallel circuit here, we have multiple paths. So I'm going to make this 100 volts. We still have the rectangular shape that we talked about earlier, but now instead of there being only one path all the way around, we've got, right now, the current can go down this line, or it can keep going to the right. Here it can go down this line, or it can keep going to the right. So we have multiple paths for the current to go. I'm going to call this resistor 1, resistor 2, resistor 3. And now I'm going to make this a 10 ohm resistor. I'm going to make this a 20 ohm resistor, and I'm going to make this a 50 ohm resistor. So let's see what we got here. Our first step is always to plug in the givens. So 100 volts, and we've got a 10 ohm resistor, a 20 ohm resistor, and a 50 ohm resistor. Okay, so what do we do here? What have we learned about parallel circuits? Well, parallel circuits, all of them get the same voltage. All right, so what I can do automatically is, if every one of these is going to get the same voltage, that means R1 is going to get 100 volts. R2 is going to get 100 volts. R3 is going to get 100 volts. So again, because they're parallel. In series, they all get the same current, but in parallel, they all get the same voltage. What we do from here then is, whenever we have two, I keep telling you, you can always solve for the third. So to find I1, I'm going to use V equals I times R. In this case, the voltage equals I times 10. Well, I has to be 10 amps. In the next one, for I2, it's 100 equals I times 20. Divide both sides by 20. I equals 5 amps. In the last one, it's 100 equals I times 50. Divide both sides by 50. 100 divided by 50 gives me 2. So I have 2 amps here. All right, so let's keep going. I still have 2 more spots here to finish. Well, I know that there are 2 amps running through this line. There are 5 amps running through this line, and there are 10 amps going through this line. Well, the 2 amps here are going to combine with the 5 amps here, and now I've got 7 amps at this point, because the 2 plus the 5 gave me a total of 7 amps. Well, this 7 amps plus that 10 amps right there, when those two combine, I'm going to have a total of 17 amps going through there. So in essence, what did we do with the currents here now to find IT? We added them up. 2 plus 5 is 7. 7 plus 10 is 17 amps. Well, as I keep telling you guys, whenever we have 2 of them, you can always solve for the third. So I'm going to say again, V equals I times R. 100 equals 17 times R. Divide both sides by 17. And RT in this case, well, what is 100 divided by 17? When we do this, RT turns out to be about 5.9 ohms. So notice that in a parallel circuit, they all get the same voltage. The currents, all right, can be added up to find the total current. 2 plus 5 plus 10 is 17. And notice here then that with series circuits, we added up the resistances, but we don't do that for parallel circuits. For parallel circuits, we have to find that total current, and then we can solve for the resistance there of 5.9 ohms. So again, what we've learned to do here then is to fill in my givens. So my voltage here is 200 volts. Notice I don't use a third one here, so I just gave you 2 resistors for this one. So there is 40 ohms and 20 ohms. Well, because it's in parallel, we know that resistor 1 is going to get 200 volts because in parallel they all get the same voltage. Because they get the same voltage, resistor 2 is also going to get 200 volts. Whenever we have 2 of the 3, I always tell you can find the third. So we get 200 equals I times 40. I in this case turns out to be 5 amps. 220. 200 equals I times 20. Well, I then turns out to be 10 amps. Well, what did we learn to do with our currents? Well, we said that this right here was going to have 10 amps flowing down through it. The 40 ohm was going to have 5 amps running down through it. So when these two combine, it's going to give me a total of 15 amps. So what does that mean? It means take our currents and add them. Well, now that I have 2 of these, again, I can go back and solve for the third. 200 equals 15 times RT. The resistance total in this case then is 13.3 ohms. Well, hey, I hope that was beneficial for you guys. I'll catch you on the flip side.